Now we have our next topic, which is engineers 3D printed personalized wireless wearable that never need a charge. Yes, it's true now, and you will see. This is basically, this article is like a custom custom customizable uh, of every body point. It's first it takes your whole body hologram, or a 3D body hologram, 3D person of your body. Then it can be designed on your body structure, uh, around like our biceps or triceps, like that. And it's like a band, I mean. And you don't want, yeah, neither you want a charge thing like in our fitness trackers right now. So it will be a great thing, I think. And it will not provide only the like uh, it will not provide your only the heart rate or a bit rate. It will all it will provide everything, uh, in every aspect, that where your body part, or where you have a problem in your body muscles, or in your body. So it will be very beneficial for our doctors also. So it can it like a regular checkup, basically, in your biceps or in your hand, wherever you like to wear it. So yes, this is all about it. And we will also like you will I will also like to see the a video about this. And it is published on it is on YouTube. So let's think, let see. Variable sensor to monitor everything from step count to heart rate are nearly ubiquitous. But for scenarios such as measuring the onset of fertility in older adults, prominently diagnosing deadly diseases, testing the efficiency of new drugs, or tracking the performance of professional athletes, medical grade devices are needed. Like I said, University of Arizona engineers have developed a type of wearable they call a biosymbiotic device, which has several unprecedented benefits. Not only are the devices custom 3D printed based on a body scan of viewers, but they can operate continuously using a combination of wireless power transfer and compact energy storage. The team, led by Philip Guthroff, assistant professor of biomedical engineering, and Craig M. Berg, faculty fellow in the College of Engineering, published its finding today in the journal Science Advances. Well, it is published on 8th October, so don't don't please get me wrong. Okay. There's nothing like this out there, said Gutroff, a member of University BIOF Institute. We introduce a completely new concept of tailoring a device directly to a person and using wireless power casting to allow the device to operate 24 into 7 without ever needing to charge. Yes, it is. Custom fit enable precise monitoring. Current variable sensor face various limitations. Smartphones, for example, need to be charged, like I said, and they can only gather limited amounts of data due to their placement on the wrist. But using 3D scan of viewer body, which can be gathered via method including MRI or CT scan, and even carefully combined smartphone images, Guthruff and his team can 3D print custom fitted devices that wrap around various body parts. Think a virtual, unnoticeable, lightweight, breathable mesh cuff designed specially for your bicep, calf, or torso. The ability to specialize sensor placement allows researchers to measure psychologically parameters they otherwise couldn't. If you want something close to core body temperature, continuously. For example, you don't want to place the sensor in the armpit, or if you want to measure the way you bicep deform during exercise, we can place a sensor in the device that can accomplish that, said Tucker Stewart, a doctoral student in the biomedical engineering and the first author of the on the paper. Because of the way we fabricate the device and attach to it to the body, we are able to use it gather data a traditional wrist mounted wearable device wouldn't be able to collect. Because these symbiotic devices are custom fitted to the viewer, they are highly sensitive, Guthrie said. Tested the device ability to monitor parameters including temperature and strain while a person jumped, of course, walked on a treadmill, and used a rowing machine. In the rowing machine test, subjects were wore multiple devices tracking exercise intensity and the way muscle deformed with a fine detail. The device were accurate enough to detect body temperature changes induced by walking up a single flight of stairs. Amazing. Continuously wireless and effortless. Guthroff and his team are not the first to adapt variable to track health and body function. However, current variables do not have the ability to track metrics continuously or with enough precision to make medically meaningful conclusions. Some variables used by researchers are patches that stick to the skin, but they come off when skin goes through its normal shedding process or something when a subject sweats, of course. Even highly sophisticated variables used in clinical settings such as ECG monitors face these issues. Also, they aren't wireless, which severely limit mobility. Patients can't go about their normal daily routines if they are tethered to bulky external devices. Yes, it is. The biosymbiotic devices that Guthruf's team has introduced uses no adhesive, and it receives its power from a wireless system with a range of several meters. The device also includes a small energy storage unit so that it will function even if the viewer goes out at the system range, including out of the house. These devices are designed to require no interaction with viewer, Guthruff said. It's as simple as putting the device on. Then you forget about it and it does its job. Like we like we like we wear a watch. That's it. This research was funded by Flynn Foundation Translation Bioscience Seed Grants Pilots Program. The team also has also been working with Tech Launch Arizona, the commercialization arm of the university, to protect the intellectual property and launch a startup to bring the technology to market. I hope this technology will come to the market. It will with the boom. I think it will going to be boom for many fitness trainer or fitness freaks.